A very good evening to one and all. On the fourth day of this 1 week virtual faculty development program cum workshop on advanced research methodology and data analysis. As you all know, the speaker of today's session, the resource person of today's session is very renowned speaker, a renowned academician, a renowned researcher, a well-known personality, Professor Dr. Manvinder Singh Pahwa, Department of Commerce, Dr. Hari Singh Gaud Vishwavidyalaya, Central University, Sagar, Madhya Pradesh. Professor Pahwa has been associated with Inspira since long time. I mean, since decade, Professor Pahwa is associated with Inspira Research Association, and he always motivated me. And in our every event related to research methodology, it will not happen without the presence of Professor Pahwa sir. And we have organized so many workshops and on the SPSS, on advanced SPSS, are with Professor Pahwa sir as sole resource person. You can find all the videos on our YouTube channel also, the Inspira Research Association YouTube channel. You can still find that videos related to research methodology, data analysis, SPSS, and etc. Even I don't remember because we have organized so many events. So you can find it on our YouTube channel. And I always, thanks to Professor Pahwa sir. He is like my big brother. He always supported me, motivated me like a elder brother. So, on behalf of Inspira Research Association and Mehta College and Institute of Technology and Swami Sahajanand College of Commerce and Management, Autonomous, Bhavnagar, Gujarat, I welcome Professor Manvinder Singh Pahwa. But before I invite Professor Pahwa to start the session, I would like to throw some light on his academic career. Professor Pahwa, an esteemed alumnus of the prestigious Indian Institute of Management, Ahmedabad, is a distinguished academician with a prolific career spanning 25 years. His professional journey is a remarkable amalgamation of academia, industry exposure, corporate consultancy, and research excellence. His core area of expertise include business analytics, entrepreneurship, business finance, and corporate laws. Beyond his academic credentials, Dr. Pahwa is a professionally qualified company secretary and has been awarded a gold medal in LLM MBA. Additionally, he has secured top ranking position in LLB, PGDHR, and PGDIB at the university level, further solidifying his academic prowess. Dr. Pahwa has been extensively engaged in corporate consultancy and has actively participated as a company secretary. His significant contributions include the incorporation and dissolution of over 200 companies, along with facilitating corporate fundraising through diverse sources, including banks, financial institutions, NBFCs, and project financing mechanisms. His proficiency extends to successfully managing initial public offerings. In the domain of executive education, Dr. Pahwa has conducted and delivered over 150 specialized courses and management development programs for esteemed corporate entities, including IIFCL, IPL, Indian Oil, ONGC, and PFCI. His expertise also encompasses delivering faculty development programs for both government and private institutions, including AICTE, ICSSR, UGC-sponsored FDPs, and UGC HRDC refresher course orientation programs. His lecture cover a broad spectrum, including use of artificial intelligence in business analytics, research methodology, pedagogy, personal effectiveness, work ethics, soft skills, SPSS, legal compliances, entrepreneurship, and financial modeling. Dr. Pahwa has actively participated in numerous national and international conferences and has chaired multiple sessions both in India and abroad. He boasts an impressive publication record with 70 research papers published in reputed national and international journals, including Scopus Index journals, conference proceedings, and books. Under his guidance, eight PhD students have successfully completed their doctoral research I don't know, the number will increase, with several more currently pursuing their PhD degrees. In recognition of his research contribution, he was awarded 3 patents in recent past. And presently, Dr. Pava holds the esteemed position of professor in the Department of Commerce and member of Academic Council, Dr. Hari Singh Gaud, Central University, Sagar, Madhya Pradesh. His unparalleled dedication to academia, research, and industry consultancy continues to set new benchmarks in the field of commerce and management education. Sir, it's a very long profile. I welcome you, sir.
Thank you.
Thank you so much, sir, for joining. Thank you so much for sparing your valuable time, sir.
Thanks. I hope I'm clear and there is no echoing.
Yes, sir. Yes, very clear, and
Okay, perfect.
audio is very clear. Video is very clear.
So, first of all, I would like to ask the participants about that. What are their expectations regarding today's particular session?
You can unmute participant. You can unmute and you can talk to Power sir directly. And some participants have joined through the name Dell and all.
No, please, because there was a clear instruction.
I already requested you.
We have to ask someone, then how it will happen.
You can change your name by, there are 3 dots. When you click on your name, there are 3 dots. When you click on the 3 dots, it reflects an option rename, and you can type your name. So please do this.
Yes, anyone, any expectation?
Sir.
Good evening, sir.
No expectation from anyone.
Good evening, sir.
Yeah, good evening. Who is this? Please open your video. Whenever you are speaking, you have to open your video while asking the questions or answering anything.
Okay,
right?
okay. I'll do. As a research scholar, I have a little bit of knowledge.
What's your good name?
My good name is Maru Khushbu. I'm from Gujarat.
Okay.
Okay. We expect to explore our knowledge more. That's it. And we have to learn too much from you. And
I also need to learn. I also want to learn too much from you. That's a real thing.
And Ravi Modi sir, thank you for this FDP. It's too much knowledge gaining. Thank you for arranging this. Thank you, sir.
Okay. Yeah. Good evening, sir. Any other expectation anyone else is having?
Yes, sir. Good evening, sir.
Yeah, very good evening.
So, as you shared some files, we expecting we will that you have to give some practical exposure. How we can we can say how we can, measure regression.
Don't worry, sir. Sir will tell everything hands on. Don't worry.
So, okay. Anyone else? Any other expectation you have from this particular day of 4 and the regression analysis we will be doing? Right. So, what do you want means what exactly the regression is and what it does, or you just want just a superficial knowledge of it, because we have 2 hours only. In that 2 hours, we have to do a lot. Okay. So, yes, Mr. Dell.
Yeah, what is your name? I will rename Miss Dell.
Sir, Dr. Parul Deshura.
Doctor?
Parul Deshura, sir.
So I will rename.
Namaskar, sir.
मैडम को नमस्कार. मैंने कहा थोड़ा सा मजाक कर ले आपसे.
नहीं सर, होनी चाहिए ना ये चीज तो.
बिल्कुल.
Sir, how do you do, sir? Fine.
Great to have you.
Now, Dr. Parul.
Let me tell you, Ravi ji, Dr. Parul Deshura is presently working as assistant professor in Mohanlal Sukhadia's University.
I know, sir,
Department of Accounting.
I know, sir. I know.
Yeah. तो नहीं, मैंने कहा पारुल जी मेरी स्टूडेंट पहले भी रही है।
मेरी पारुल जी से बात हुई थी सर अभी 3-4 दिन पहले।
जी 2014 में हमने एक फिजिकल वर्कशॉप करी थी आईए के बैनर पे। देन
आपको कौन नहीं जानता सर?
मिला था तब आप शायद उस टाइम पे जेआरएफ थी मैडम।
यस सर आई वाज जेआरएफ एट दैट टाइम सर।
यस आई
ये
अंडरस्टैंड।
तो अच्छा है सर, उस टाइम में और इस टाइम में काफी गैप आ गया है, बट लर्निंग की तो इच्छा अभी भी है, तो सर आई होप कुछ और
मैडम थोड़ा लेट जुड़ी
दाढ़ी
अपने से।
सफेद हो गई ड्यूरिंग द टाइम।
मैडम थोड़ा लेट जुड़ी सर अपने से, इंस्पिरा से।
सर आई हैव जॉइंड इंस्पिरा सर।
अरे ग्रेट ग्रेट
यस
ग्रेट।
सर।
रवि जी ये मुझे परसों पढ़ले रोज पारू जी ने कहा था, तो मतलब इट इज अ वेरी गुड प्लेटफॉर्म मैडम, आपको
Yes, sir.
काफी बेनिफिट होगा
She
इससे।
has already become life member also, sir.
Yes, sir.
She has become life member. She asked me, and I urge to all of you, those who are not life members over here,
No,
because
it's
see,
up to
the
them,
people
sir.
of the structure of means the government universities, even from my university also, many people I have suggested them to join Inspira, and Inspira has crossed, I think, 10,000 of their membership. And particularly Parulji, and even to I am addressing to everyone.
Yes, sir.
Inspira is having certain very good journals.
Yes, sir.
Right,
Yes.
And
Yes,
I am editor of 4 of them.
Yes, sir.
And
I
these
visited the
journals,
website.
yes, ma'am. And these journals are registered with Crossref, and these are means very highly cited also. Because whenever we are publishing at such a good place and we get good citations, that what is our desire, that if we are publishing our good work, it should be cited by many.
Sir,
So
this is
that
all because
particular
of you.
platform this Inspira is providing.
Sir, during the workshop also I am observing that participants from Pan India are there.
Ji.
And speakers are also from like in an international level and national level. Both
very,
the
very,
communities
very
there at the
very
part
correct.
of participant as well as at the part of speaker. Sir,
Yes,
Dr. Ravikant Modi sir is very doing very good work, sir. Great job he is doing.
Ravi ji is always active. Ravi ji is...
Sir, you know, the Professor Pava's contribution, I can't tell you the contribution of Professor Pava's in my career also, in Inspira also, and
आपका बड़प्पन है भाई.
the things which you are, which you are seeing like Crossref and all that, it is all because of Professor Pava sir. उन्होंने मेरे को ये सब सिखाया कि हाउ टू टू मेक द जर्नल्स गुड.
नहीं
सर का एक्सपीरियंस तो सर सभी को ब्लेस करता है और सभी की सर एक्सपेक्टेशन को मीट आउट करता है.
पर आपको रवि जी एक चीज नहीं बता रहे, मैं बता देता हूँ. ये आशीर्वाद जो है ना एसएस मोदी साहब से आ रहा है.
सर वो तो खैर
जी के फादर है ना. तो ये वहां से जो आशीर्वाद है बस यही वापस वही जा रहा है, आप यूं समझ लीजिए. तो वो वाली बात है. रवि जी इज डूइंग वेरी वेरी गुड एंड आई हाईली कांग्रेचुलेट हिम. जी. तो ठीक है, फिर वर्कशॉप स्टार्ट करते हैं.
बिल्कुल.
जो रिग्रेशन एनालिसिस के बारे में, लेट मी जस्ट शेयर माय स्क्रीन. जस्ट शेयरिंग माय स्क्रीन टू ऑल. Just a minute. I think now you are able to see my full screen rather than the half screen.
Yes, sir.
Right?
Yes, sir.
Very perfect.
Okay. So regression analysis, when we talk about, actually it is a procedure And this procedure is designed to perform either a simple regression or multiple regression. We will be doing it. But for ensuring more clarity and understanding, we will understand this in two different phases. Okay. So first phase will be the simple regression, which we will be taking up. And this will provide an introduction and base for studying the multiple regression or multivariate regression. Say, okay, so this will be the thing which we will be doing. So in case you face any problem, so just please tell me at the moment itself, right? So that can be done using the raising of hands and other things, right? So let us start with a situation, because in order to understand this, we need some situation. So this situation is like a very simple situation, and I have already given this SPSS file of this situation to all the participants, right? So the vice president of a large chemical and manufacturing company, actually, he believes that the firm's annual profit depends on the amount spent on the this R&D. The new CEO has asked for the evidence for the same, and the following is the data. The R&D expenses are given and the profits are given. So from 2010 to 2015, if you see, the R&D expenses in lakhs or crores or in millions, you can say 2, 3, 5, 4, 11, and then 5. So there is this, and if you see the profits, so in 2010, it starts with this 20, 25, 34, 30, 40, and 31. This is something is given over here. Now, the vice president of R&D, the VP R&D, wants to predict the annual profits from the amount which is budgeted for the R&D. Means he is specifically clearly saying that if I am spending so much of money, particularly on research and development, what should I keep on spending, or how it is related? So this is the situation. So how it can be done? Now, the basis of decision making actually is with this regression analysis, right? So the research question and decisions are often intuitive in nature, particularly when we are talking about regression. So future outcomes are based on the present decision which we take, right? And there is a effective, you can say, research decision to be based on the past experience. We are taking certain decisions which are to be taken in the future, and we are actually making the predictions and the forecast, and which are dependent on the interrelationship among the variables, you say. So on the basis of what is already known, the prediction and the forecast are made. But the question is how we can make. Actually, what the thing is, research, if we see it from that point of view, is just like an iceberg, you can say. What is the quality of iceberg is that we only are able to see a little portion which is above the sea level, and what is below the sea level we cannot predict. If we are able to understand and know what is beneath the sea level, we would be able to take a decision in a better way, and that what could not happen in case of Titanic, and that was the reason why it sunk, because the crew members were not at all able to understand what is just beneath it, and it actually cracked the entire the vessel from below, and this gigantic vessel, or you can say the gigantic ship, sunk actually at that time, because it was not able to understand and take the decision at that point of time, right? So if it can be determined how the known is related to the future event, it can be considerable aid to the decision making. That if we are able to understand that with certain probability that what can be the future thinking. So regression actually tells us how to determine the relationship between the variables. So this workshop is actually about determining the relationship and predicting certain things for the future, right? So another question is how it is different from chi-square analysis and correlation. So this is something, because why I should go for the regression analysis only when I understand and know the chi-square and the correlation. And I hope you have already studied about the chi-square and the correlation in the previous days of the workshop itself. So how does it different from the chi-square and the correlation? That the chi-square, if you say it, actually it tells whether there is any relationship or association between the two variables, but it does not tell what type of relationship exists between the two variables, right? So correlation and regression analysis show the nature and the strength of the relationship and how these are different. Actually, correlation determines the degree to which the variables are related, whereas a regression shall develop a estimating equations and tells how the known variable is related to that of the unknown variable with which we are making the prediction. Okay, so correlation analysis tells the direction of the relationship, whether it is positive or negative, whereas a direct or an inverse relationship is there or not, and what type and what is the degree also. Whereas this regression analysis actually describes and predicts the unknown variable on the basis of the known variable, right? So this is what it makes different, because when we are predicting certain things, when we are estimating certain things for the future, definitely it requires a strong test to be applied, or it requires certain you can say relationship, that in order what will be the relationship and how it can be explored can better be learned from today's workshop itself we will be doing. So what regression actually is. So Professor Dalton in 1877, for the first time, he used the word regression in his study of predicting the heights of children from the heights of the parents. Means his hypothesis was that those parents who are taller are having taller kids. And he showed that the heights of the children born to tall parents tends to regress or move back towards the mean height of the population, and that's what is the hypothesis he used. Okay, so this is something which is related to converging towards the mean, particularly when we and mostly we are talking about mean in all the hypothesis testing, whatever. So what are the variables in the regression which we study? So on the basis of the discussion we just had, it can be determined we are talking about some relationship, right? There is some relationship, and this relationship is between the two variables. Okay. So and one of these variable is known to us, and on the basis of this known variable, can we predict the unknown variable also? So this is what we are doing, and the value of the unknown variable to be determined is on the basis of the known variable. Therefore, the known variable is called independent variable, because we know it. It changes. It changes along with what we want, and the unknown variable, because the value of the unknown variable is dependent on the independent variable. That's why it is called dependent variable. So unknown variable which we are going to predict is the dependent variable, which will be depending on the known variable, which is called the independent variable, which we are already knowing. So what we will be doing over here is we will be tweaking the independent variable in order to find whether or what changes it actually does in case of the dependent variable, right? So let us talk more about independent variables. Let us go to this particular large chemical company R&D, which we have just now we have discussed about. So what will be the independent and the independent variable in this? So in this, actually, we are predicting the profits, because if I am keep on doing some expenditure on R&D, what benefit I am getting, I am interested in knowing that. Okay, so what I'm doing is that I'm just asking about if I predict that I will be spending this much on the R&D, what will be the profits of the firm, right? So independent variable is expenditure on R&D, and dependent variable is the profits of the firm. And what is the nature of question arises that what is the nature of the relationship between these two? So what is the nature of relationship between independent and the dependent variable that we will be exploring, right? So what type of relation, whether it is having a direct relation or whether it is having an inverse relation. So direct relation, when there is increase in the value of dependent variable with increase in the value of independent variable. So we are tweaking independent variable, we are increasing the independent variable. And if with the increase in the independent variable, the dependent variable also increases, then we can say there is a relationship, means it is having a direct, means independent variable we are increasing and dependent variable also increases. So R&D expenses in the profit, if we can say that if we increase the R&D expenses, the profit may increase. If the number of cars on the roads are increases, then there is higher probability chance of the accidents. When there is higher population, for sure the water consumption by the population will also be high, right? Inverse relationship means when we decrease one value and the independent value also increases. One means one is decreasing but other is increasing. So decrease in the dependent variable with increase in the value of independent one and vice versa will be called as an inverse relationship. So we can just depict it with the arrow. If you see, if there is increase in the independent and there is a decrease in the dependent. So number of pollution control equipment and the intensity of the pollution usage. If you increase the pollution control equipment in a factory, the intensity of pollution will decrease. Okay. Likewise, there is an inverse relationship between a very famous example of law of demand, right? If the price increases, the demand decreases. So there is an inverse relationship, you can say, right? So further, if we talk about what is the basic nature of the relationship in the R&D expenditure in the profits in case of large scale chemical industry we have done. So is it a cause and effect relationship? Causal effect relationship is there. So actually, if we see the regression, mostly the relationship found is causal. That is, the independent variable causes the dependent variable. This is most, but there can be cases wherein some of the other factors, that is, which are not a part of the study, is causing the change in both the variables, right? So that it means that whenever we are applying regression, it does not actually always means that there will be a cause and effect relationship. So whenever this question comes that does regression actually implies or applies a cause and effect relationship, the answer can be no. There can be some other variable which may affect both the variables, okay, which is causing both the variables, and we cannot establish relationship. So actually we can give an example, the sale of a diamond jewelry and the sale of new luxury cars. Now see, both the things, sale of diamond jewelry and this new luxury cars can increase. So what the thing is, you can say that because of the sale of diamond jewelry, the new luxury cars, the sale of new luxury car is happening. No, it is not the thing. It is just that the GDP of that country might be increasing, in which this particular things are to be studied. Okay, that may cause. So is one causing other? If we ask, then we can say there is no relationship between these two. But yes, there can be a relationship when we are talking about increase in the number of increase in the gross domestic product of that country, or increase in the disposable income of the people of that particular country, those who are having the high you can say the income of that particular country. So in that case, it may be possible that the diamond jewelry and the luxury cars may get increased, right? So next is the relationship in the regression. Therefore, the relationship found by regression may be a relationship of association, not necessarily be the relationship of cause and effect, right? So it is not always causal relationship unless there is a reason to believe. Okay, unless there is a reason to believe that the change in the value of the dependent variable are caused by change in the value of the independent variable. Let us take the example of this. I have just not displayed. Actually, what happened? There is a hot and sunny summer is there, right? And there were increase And actually what has happened, that something in the newspaper got published, that the increase in the ice cream sale has actually increased the homicides. Okay. But if we closely look at it, homicides were increasing because of this hot and sunny summer. Sorry. People have started going on the beaches. Okay. And more people going on the beaches, definitely there are more, you can say, deaths happening. And because of the summer also, only the sale of ice cream has increased. So the news in the newspaper that the sale of ice cream is causing deaths means here the sale of ice cream is increasing, and at the same time the deaths are also increasing. This can be a wrong hypothesis, or you can say this if tested, this can prove to be a wrong one. Okay, but the cause is something else. Which, so here what we are doing, we are studying two things: sale of ice cream and increase of homicides. So if we see these two variables, both of these variables are not affecting each other. Both of them might be independent of each other, but there is some another variable in the study which is causing both of these. So why I'm telling you all these things? Because whenever we are applying regression, we must be able to understand that regression is not always, it does not always establish its cause and effect. Because the way I'm teaching, the way I'm telling you that if you increase or decrease the independent variable, there will be some effect or impact on the dependent variable. It doesn't mean that the independent variable is causing the dependent variable. Okay, so there can be instances we have just now. Okay, so let us just understand the procedure of regression, how to do it. So the most basic and the easiest way to know and understand the relationship and the direction of the relationship between the two variables is the scatter plot. Okay, so if the scatter plot is, you can say, is going up. Okay, so if you see the scatter plot going up, you just see the first case. So it actually establishes a strong positive correlation. Okay, and if it is the scatter plot is more scattered, okay, it's far away from the line, or you can say if you have to draw a line, it is difficult to draw a line, but still you can draw it. There can be a moderate but positive relationship. And if you see the third one, there is no relationship at all. But at the same time, if the scatter plot direction is going down from left to right, we can say that there is some moderate negative correlationship. And this can be strong also if the the scatter of the dots are is near to the line. One more thing is there can be a curvilinear type of relationship can also happen, where it follows, like you can say anxiety in the performance. This is a very good example of giving it as a, you can say, curvilinear type of relationship. So now how to estimate the using regression? So as a scatter diagram which fits the regression line actually visually among the data points, therefore the chance of error is very high, because there you can just somebody may prepare the line, but if you ask someone else, they can actually may not be that much accurate. Okay, so they can tweak the line up and down. So the chance of error is high. Even when there is a strong correlation, you can say, so the type of estimation, if you do so, there can be multiple estimated lines which can be done. But if the same is predicted using a mathematical equation, it will give a better fit, I would say, right? So therefore, the regression analysis is a process of developing a statistical model. Now, what actually we are doing? We are developing a model which is used to predict the value of the dependent variable. That is y. Y will be the dependent variable by at least one independent variable. So there can be more than one independent variable also which may be affecting the dependent variable, and it practically happens. There is not only one variable which is affecting. Okay, so whenever there are more than one independent variable which are affecting, then it will be a multiple regression model where more than one independent variable are changing the value of the dependent variable. So in simple way, or in simple linear regression, there is only one dependent and one independent variable, right? So mathematically, if we want to write it, so y is equal to a plus bx, we can write it in this, right? Where y is the dependent and x is the independent variable, and a, which actually remains constant, is the intercept, and b is the slope of the line. So using this equation, the value of y can be computed for a given value of x. A is a y-intercept because this is the point at which the regression line actually crosses the y-axis. And b is the slope of the line, which represents the change in the dependent variable y with a unit change in the independent variable, that is x. So what actually we are doing? We are tweaking x in order to know the value of y. So x will be tweaked in order to know the value of y. Accordingly, the things will, right? So let us just take an example. What will be the value of y for a given value of x is equal to 5 if a is equal to 3 and b is equal to 2? So I would like to have answers from you. Let us make it interactive. Yeah, come on. You can write this equation. Y is equal to a plus bx, right? With the help of this equation, you have to tell me the answer to this. Yeah, come on. Anyone? Yes, Sumanna, Shweta Kumari, 13. Okay. So the answer is 13. Vivek Kumar also has got.
Yes, thank you.
Subhi Rathod. Excellent. Very good. Okay. Kostubben, 13. So 13. So 13 is the answer. So what will be the regression equation? If I ask you, then what is the regression equation over here is y is equal to a plus 5b, because x, the value of x is 5 and a and b are the intercepts. If I try to understand the regression equation with which I can predict the other values also, then y will be equal to a plus bx. Now with given values of a and b, I would be able to calculate the estimated value of y, right? So finding the values of numeral constant, that is a and b, that is also very important. So let us just assume this figure. So let us just assume that the equation as we have discussed is over here if we have kept it. So visually we can find out a is equal to 3. That's what we have estimated in the last here it is given a is equal to 3 and b is equal to 2, right? So assuming that a is equal to 3, as the line is crossing the y-axis at 3, right? So a is equal to 3. Please see the graph, right? Now to find out the slope of the line, that is b, we must determine how the dependent variable y changes with the change in the independent variable, right? So for this, just assume 2 points on the line. Point A, and the point A, the coordinates are 1 and 5, and point B, the coordinates are 2 and 7, right? So in notation, we will write A x1 y1 and B x2 y2. Okay. So first point is x1 y1, or you can say 1 comma 5, where x1 is 1 and this y1 is 5. And this in the same way, in the second point, that is x2 y2 or 2 comma 7, you can say. So y2 is 2 and x2 is 2 and y2 is 7, right? So what will be the b? The value of b will be, because it's the slope. So slope, when we are calculating the slope, then we have to take the ratio of y's and x's. So what is the change in y as compared to change in the x? We would be able to understand what the slope will be. So b will be is equal to y2 minus y1 upon x2 minus x1. Why? Because we are trying to find the change in the value of 1 with respect to change in the value of. That's why we are dividing it, right? So b will be is equal to 7 minus 5 and 2 minus 1. Okay, tell me the answer, what it will be. Come on. B will be is equal to 2, right? And that's what we have also given in the last equation, that what is A and what is B, right? So let us, we have actually found out these things. So what will be our given equation? So y is equal to 3 plus 2x. Now at that time we were knowing the value of x, and here we know the value of A and B. Normally we know the value of A and B, and we have to predict, and we have to put the value of x, then we can find the things. Okay, so find out the value of y if x is 7. Suppose that x is 7, then what will be the value of y? Come on. Okay, exactly 17. Okay. Uday Gadia 17. Fine. Vivek Kumar also. I hope you are understanding. So it can be observed that the slope of a regression line is a positive and it is direct, right? So it is actually showing a direct relationship. If you see the line also, from line also we can say that the line is going up. So there is a direct relationship which I told you before. Okay, so let us find the values of the numeral constant A and B. So let us take another example. Okay, so this is another example we are taking in figure 2. The 2 points are A 0, 6 and B 1, 3. Okay. Okay. X is 0. A is 0, 6 and B is 1, 3. So what will be the intercept and the slope of line? I just need the answer immediately. Yes, come on, calculate it. 2 lines you are having, 2 things, and you already have the figure with you. B is 6 and sorry, A is 6 and B is 3. Yes. Okay. And what will be the regression equation, Madhvi? In that case, the regression equation will be intercept is 6. We already know, because this is cutting the line at 6 point. Okay. And slope is, we have to calculate the slope y2 minus y1 divided by x2 minus x1. What it will be? Minus 3. Now, if you see, the slope is coming minus 3, not 3. Dr. Jatin, it will be minus 3, not 3 exactly. Okay, y2 and y1. Okay, y2 is 3 and y1 is 6. That's why it will give you minus. Okay, right. So this is minus 3. And what will be the regression equation? What will be the value of y if x is equal to 2? How will you calculate, or how will you determine? 0, isn't it? And what it will be? Y is equal to 6 minus 3x. Previously it was plus, and 6 minus 3, right? So let us now learn about the method of least square. I hope now your base has been formed that what regression is. We have already talked about certain good things over here, right? So regression analysis, if you see it from the point of view that as of now, we have seen that how to determine the equation for a straight line. So this is what we have done till now. But in general, we try to estimate the trend by drawing the line through the middle of the set of the points in the scatter diagram. That's what is practice. If you see this particularly in the graph, we are trying to put a line in the center of the scatter diagram. Now, we will understand how to calculate an equation and that of the of that particular line, where we are putting the line in the middle of the this scatter diagram, and that too very accurately. That what will be the line, or what 2 coordinates should I join in order to get a better line, right? So for an statistician, the line will be having a good fit. Okay. If it minimizes the error, okay, between the estimated points on the line and the actual observed points that we have used to draw it. Okay, seeing the figure besides, it is now clear that the line of estimate in regression analysis cannot exactly cover all the points. Can you cover all the points? Can you cover all the points on the scatter plot? So there are a large number of points around the trend line. This line is called a trend line. So there are large number of points around the trend line which are far away. That's why it is called a trend line, because it estimates or it predicts. It cannot accurately satisfy all the points, right? So here is a time to introduce, you can say, a new symbol. Okay, we can introduce a new symbol over here, and this symbol is Y hash. Okay. Okay, so this is, if you see the equation, Y hash is equal to A plus BX, right? So here, what we are using now, so far we have used Y to represent the individual values of the observed point, right? And these observed points we have measured along with the Y axis. Now we should begin to use Y hat, or you can say Y hash, whatever, to symbolize the individual values of the estimated point, that is the point that lies on the estimating line. So accordingly, we shall write the equation for the estimating line as such: Y hat is equal to A plus BX, right? Now we are not using Y, we are using Y hat or Y hash, whatever, right? So here is the thing that we are, because why it is so, I have just now told you the reason, that it represents the observed point. It is not exactly the thing, because it's an estimated thing. That's why we cannot exactly use the things as such, right? So one more thing is there. If you note that we have been using this I have already told you, yes, that why we are okay, fine, that this is already done. That Y hash actually is for the predicted line, not the exact line as such. If you see. Now let us consider a figure of A where the three actual observations are plotted. Okay, now there are three actual observations, and you are asked to draw a trend line. Okay, how will you draw it? Now these 3 points are there, which are 4, 8, 12, 6 and 8, 1, and you are asked to draw a trend line. How will you do? You will do something like this. Okay, something like this. Now probably this cannot cover any of these points, rather. Okay, so what is happening is, it is having certain points. So these points represents the trend line which are over here, which are different than the actual points. Now actual points were this 4,8, 12,6 and 12,4. So only one line, 1 point, 8, 8, 8, 8, 8 and 1, the last one. Yes, these were the, so none of the actual points are on the trend line, but there are certain points on the trend line. So the net effect of these differences, if we see, can be studied. So these points on the trend line, I would say, are the estimated points, which are obviously, which are different from the actual in the way. And what is the difference? I would say, if you see it from the y-axis point, the difference will be y minus y hat. Okay. Now these differences are 8 minus 6, because if you just calculate the differences only for the y, because this is something on the y-axis. So 8 minus 6, 1 minus 5 and 6 minus 4, and if we see the net, it is actually 0. So the net effect of the differences in the actuals and the estimated here is 0, which depicts that there may probably, it may probably be a good fit, right? Because it is actually giving you the 0 effect. So all the things which are to be considered are already considered over there, right? So can there be any other way to plot the trend line? I have just plotted the trend line over here the way I have done it, right? It is something like this, right? And can there be another way to draw the point? So let us consider the another line which is plotted on the same actual observations are plotted, right? So let us see, this is the line. Okay. So again, the points on the line are y bar will be different from the actual observations y. Okay. And it can be different in this way that y minus y hat or y bar or y hash, it can be 8 minus 2, 6. Okay. 1 minus 5, that is minus 4, and minus 2, that is 6 minus 8. So again, you see the net effect of the difference in the actuals and the estimated here is 0, which is again depicts that it may also be a good fit. Now the question is, previous line, if you see, was having a downward slope, and this line is having upward slope. So what should I consider as a best one? Right? So if we determine the good fit, how will you determine the good fit? So this is what the actual differences are. So the differences in the actuals of the observed y and are estimated, and the estimated y are nothing but the errors. These are called errors, and these are depicted by Ipsen because the trend line is not able to predict or perfectly estimate the actuals, and therefore the difference is called an error. So what is important to note over here is that then one line is showing downward trend and there is another line showing upward trend, which is the best fit. We would like to understand that, then we have to just consider it in further way, right? So if we just see a quick you can say visual examination of the two estimated lines, in it reveals that the line in the graph A is a better fit than the line in the graph B. However, our process of summing these individual differences indicates that both the lines describe the data equally. Okay. Now, if you see it from that point, so thus we must conclude that the process of summing the individual differences or calculating the error is not a reliable way. Why? Because the line in the figure A is looking as if it is a better fit rather than the line in the figure B. But if I try to do it by adding the differences, it will confuse me. So the problem with with adding the individual errors is the cancelling effect of the positive and the negative values, if you see, and it is actually giving me 0. So from this, we might conclude that the proper criteria for judging the goodness of fit to add the absolute values, that is whatever we have done of each error, it is not a proper way of doing it, right? So what can be done? So how will you be able to determine a better fit? So let us try adding the absolute values. If we try to add the absolute values, means that we are just ignoring the signs, right? That is plus and minus. So 8 minus 6, 2, 1 minus 5, minus 4, but we will be considering 4. And 6 minus 4 is 2 as such. 8 minus 2 is 6. 1 minus 5 is again minus 4. We are considering 4. And 6 minus 8 is 2. Now, if we total the absolute error, the figure A is giving me an error which is less than the figure B. So the absolute error in figure A is smaller than the absolute error in the figure B. So can we now confirm that the estimated line in figure A is better fit than in figure B? And can we conclude that? Yes, the situation says like that. But before this, let us just consider a different, or you can say mutually identical situation, right? So if we try to determine, we can just try to consider the new situation where these blue points on the estimated, these are the estimated points, whereas only without this, if you try to see this from this point of view, let me just show you. Okay, can you see these points? These points, this one, this is actually, and this particularly the blue ones. The blue ones are the estimated ones, right? Whereas these are the actual points. That's why the error is being calculated in this way, right? So that is how it is. Okay. So let us just see this particular situation where you can just see this if we see 4 minus 4 over here, it is 0. 7 minus 3 is 4. 2 minus 2 is 0. Again, the total is 4. Right. So here we are considering a different situation with the total absolute as such. So here, if we try to see which is the better fit, we can conclude that the process of summing the absolute differences for calculating the error is not a reliable way to judge the goodness, because it is again coming just similar to it. So why the sum of the absolute values does not stress the magnitude of the error? This is the important. It seems that it seems reasonably that the farther away the point from the estimated line is, it is more serious the errors. So we can afford to have several small absolute errors rather than a one large. That's why a one large error will become the outlier at the same time. Now we have to find a way to penalize the large absolute errors so that we can avoid them, right? So even not only summing, even not the absolute values, but there can be something more which can actually tell us to just do the things in a better way. So the goodness of fit can be determined by the least square method, and you will find that this is the method which is an appropriate method to just go with estimation itself. Now, if you square the differences, right? So squared error will penalize it more, and smaller than the squared error. In if you try to see this, what is the effect of squaring? The squaring not only weed out the signs, that is plus or minus, it also increases the magnitude of the higher level. Okay, so with the same thing, if we try to do, you just see if we keep on squaring the errors. So 8 minus 6 again is the error. It's the square, and the difference is 2, and the square will be 4. In the same way, all things we have squared, and we can conclude that figure A is a better fit than figure B, whereas figure B is giving me a total, you can say, estimated error is 56, whereas in figure A it is 24. So what we are doing, we are actually and that is the reason why this method is called the least square method. So we are actually squaring the differences, right? So it cancels the effect of the positive and negative values, and it magnifies or penalizes the large values. That's why this is a better one, and that's why we consider the least square method as a best method of calculating or you can say estimating the line as such. So using the criteria, so yes, any question up till over here? And why the method of least square method, why this method of least square is called least square? The answer lies over here. Okay, I hope you are able to understand this, because a lot of effort has been, you can say, put on in order to make this particular slides, in order to make you understand that why we call least square right? Okay, let us just proceed further. So we understand that what the method of least square is and how we calculate it. These are the things which are given over as such. Okay. Yeah. So using the criteria of least square, we can determine whether one estimated line is better fit or not, or what. Okay. So these are the formulas which are there. So to solve this, the statisticians have derived two equations we can use to find the slope of slope, that is b, and y, the intercept for best fitting the regression line as such. So slope of the best fit is given by this formula, which is given as summation of xy minus n x bar y bar upon summation x square minus n summation x bar. And the intercept, that is a, can be calculated as y bar minus b x bar as such, right? So this is the thing. Further, let us see the applications of regressions, that how the regression is applied and what are the situations in which we can apply the regression. So there are several things which will be covered and which are covered in this introductory chapter. You can say we have already covered about the concept of the predicted value and the regression equation also, and the relationship between the correlation and regression also we have done, and the proportion of variance in one variable which will be explained by the other, and further we will be going for a test of the curvilinear relationship too. So these are the things that are you can say the applications of regressions as such. So suppose the administrative, so this is another situation we would see. Suppose the administration of the Bright Future School in this is one of the school in Jaipur. Okay, in Bhavnagar. I also used to reside there myself, so I've just taken this as such. And it is actually trying to see the relationship between the age of the school bus and the annual repair expenses they should expect to incur. Okay, so for establishing this relationship, the director has gathered the information about the repairs of the expenses considering the four of the schools. So there are four school buses, and it has considered the four school bus number is A, B, and C and D, and the age of the bus is A, and it is taking during last year in 700 rupees have been spent on this particular 7,000 you can say at that time, and B, the age is B bus is having the age of 3 years, again 7 is spent on it. C again is having 3 years age, but 6 is spent, and D is 1 year, but 4,000 has been spent in a repair. So what can be the slope? So we are given certain things, and age of the bus is independent one, and the repairs on it will be the dependent. Okay, so the slope of bus fit, as we have just now understood the formula of this, can be calculated as such. So if we try to calculate it manually, so we can just take the mean and then the summation and the mean, and we can put it in this formula, and we would be able to arrive uh, at it. So if we just keep on adding it, it is 12. It is coming to 12 as such, and this repair expenses, if you see, this is a 7, 7, 6, and 4. So the total is coming to be 24. And X and Y, if you multiply it both, and then you just total it, it is 78 and X, because whatever is required in this formula, it is what it is. We are calculating the same. Okay. So now this particular thing will come to be 0.75. That is B. That is the slope of the best fit will come to 0.75. Y is intercepted. You can say 0, or Y is intercept. That is A. If you want to calculate. Okay. Can you please calculate this for me? How much it will come? The Y intercept, which can be depicted by A. Y bar minus dx bar. How much it will be? B, you have already calculated 0.75. Yes, come on. Quickly, because otherwise we will not be able to do that multiple regression. Yeah, come on. No answer till now. Yes, Monica, 3.75. Okay. Exactly, 3.75. Anyone else who has calculated this? Okay, Shweta also has done. Great. So what will be the regression equation in this situation? Great, Khushbu Ben. Yeah, what will be the regression equation? Excellent, Nikhat Nasreen. Good. Yeah. What will be the regression equation? Anyone? You have the value of A, you have the value of B. Y is equal to A plus BX. What will be the regression equation? It's very simple.
Linear.
Yeah, 3.75 plus 0.75x. This will be the regression equation. Okay. So let us try to use this SPSS. Excellent, Suman Chatterjee. Sumanna ji, good. Use of regression equation. So I hope you all have SPSS with you. So I have already given you this file particularly, which is called the Bright Future bus file. So can you please open that in SPSS? Double click it and it will be open in your SPSS itself. Done? Those who have done, please acknowledge. It's opening. Keep opening. Please use two screens if you can, if you want to have the better one. So on one you can just apply the things, and on another you can, yeah. Shweta, if you don't have SPSS, no issues. You can just see the procedure over here. Afterwards, because files already you have. Raviji has sent you all the files, and then afterwards, what you can do is just see the video and try to apply it on your system itself. You'll be able to get it. Okay. No, it's okay. You can do it after. Okay, so if you want to create the variable view, I will show you. So this in variable view itself, you can just bus number. You can just put the age of the bus. That is what we want to do, and repair expenses. That is. So these are the three things which we have. So bus number is a string A, B, C, D, right? And both the things are numeric otherwise, and you can just label it and you can put it as such over here. And you can create a data view, because as soon as you will be preparing this, you will get the data view. So A, B, C, D, you can put and the figures which you have 5331 for the age of the buses in years, and repairs in rupees 7764 you can put. Okay. So this is how. So now you go to the analyze, go on regression. Anyone is doing with me? Anyone there doing with me? I have also told you how to create the variable view and data view, particularly in SPSS. Okay. So go on analyze, go on regression. Okay. And go on linear. Okay. Now after that, because you have two variables. So one is this repairing expenses. You just put it as a dependent variable, and independent variable is age of the buses, because we want to understand and know what will be repairing expenses if we have, suppose if the age of buses keeps on going. It means this is something which is related to decision making. So the school is thinking whether it should go for a new bus or not. So here we can tell it as such. Okay. So just you can just put these as such, and you can press OK. As soon as you will press OK, you will get the solution which is given over here. Solution of SPSS, right? And if you see carefully here, this is the slope of the regression. That is B you have got. Okay. So B point is the slope of the regression. This is the intercept which you have got as such, which in bracket it is given as a constant one. Okay. So what will be you are now having A and B both. What will be the regression equation? B hat is equal to A plus BX. 3.75 plus 0.75x. We have already done it. So it was just a thing to, you can say, cross check it whether we are doing correctly or not. Okay. So I have already told you the manual one. I'm now here also. If you put it in SPSS, you have got both the things, the constant and the intercept, that is, or the slope, you can say A and B, and you can formulate a regression equation using this particular thing. Okay. So with the help of the coefficients table, you will be able to understand and know, or you can prepare a model which can be tested further. Okay. So regression equation over here is this, and you can, and this is the same as that we have got by doing it back. Okay. Are you able to understand, everyone? Okay. Now see, I just understand and I want to know what will be what will be the expenditure if my bus is 4 years old. Okay, so the director can use the equation to predict the annual repair expenses, putting the value of x as 4, rest all things remaining same. So what is the value of the this annual repair expenses? 6.75. So thus the school might it might expect to spend about 675 rupees annually, because it is in hundreds, in repairs of a 4-year-old school bus. Now we can solve the opening problem of the chapter, where we tried to understand the relationship between the R&D expenses and the profits. Can you do that now? Can you do that now? Finding the value of A and B. Okay, in which we have done this, and I have already given you one more file, which is R&D expenses, R&D and the profit file, if you see. So this was the situation in which we have, just for your reminder. Okay, so you can use the SPSS and show the regression line on the scatter plot, and you can also see the regression equation. Besides, if the firm spends, the question is, if the firm spends 8 millions, how much profit it will earn, we have to see. So also you can manually estimate the this y hat for each values of R&D expenses. So this is the sorry, this is the entire you can say the model summary, ANOVA, and the coefficient. With the help of coefficient itself, if you try to find out, you can actually see the regression equation for that particular thing, the opening, starting, or you can say opening problem which we have taken is y hat is equal to 20 plus 2x. So this is the regression equation which you have got. Intercept is given to as 2, and regression slope of the regression is given as B. So this will be the regression equation as such. So firm, and if you using this regression equation, if you try to find out how much is the estimated profit which can be earned if 8 millions are spent, can you do that for me? Please do it using this equation. If the firm spends 8 millions, how much profit it will earn? 36. Very good, Shweta. So you have to just put the values and you will get the profit 36 as, right? So in order to run this in SPSS, what you can do is, or you can just want to see the graphs. So go on graph, go on this legacy dialogues, go on scatter plot. Okay. So as soon as you will click the scatter plot, you will find this type of box coming up. Okay. And choose this matrix scatter over there. Okay. So choose the simple and define. You can also, right. So as soon as you will choose it, go with the this simple scatter. Go with this defining certain variables. So as soon as you will put define, then you have to define y-axis and x-axis, that what is on the y and what is on the x. Define it as such, because y-axis comprise of the annual profits which we are going to predict. That is the dependent variable, and x is the independent variable, R&D expenses. You put it over there. Okay. And then you can just press OK. So you will get such a scatter plot out of it. Okay. Now we know how to calculate the regression line, and we can learn how to check our work, right? Roughly, if you see, the accuracy of the estimated equation can be done by examining the graph of the sample points. Okay. And it can be seen that the regression line in the figure over here does appear to follow the same path as you can say prescribed by the sample points itself, right? Okay. Fine. So you can just check the estimated equation. The accuracy can also be assessed mathematically. So you can, if you want to check, you can check it. Y and Y bar, or Y hat, you can just calculate the individual error. The total error will come to 0, and which actually tells that it can verify the present problem as such. Now, next important thing is what is the standard error of estimate. So from amongst the lines in the figure A and B, which is more accurate? You just tell me. Okay, and figure A and figure B, if we try to understand. So as we have learned that that a line is more accurate as an estimator when the data points lie closely to the line, right? Like if you see this figure A, the scatter points are close to the estimated lines, right? And if the lines if the scatter points are farther away, the line cannot be said to be more accurate. So reliability of estimated equation can be mathematically measured by the standard error of mean, which is denoted by SE. So what is the mean difference, or you can say the difference between standard this SD and SE? Okay, what is the difference? Anyone? Standard deviation and standard error. What is the difference? Anyone? Okay. So standard error is similar to the standard deviation, as both are the measures of dispersion only. Okay. The only difference is that the standard deviation is a measure of dispersion about the mean of the standard. Okay, it's the dispersion about the mean. Standard error measures the variability or the scatter of the observed value around the regression line, right? So if you see it from the formula itself, so notice that in the equation which is calculating the standard error of estimate, the sum of the squared deviation is divided by n minus 2. Can you see that in the standard error of mean? And it is not divided by n, or you can say n minus 1. Why it is so? Anyone? This is because we are losing the 2 degrees of freedom in estimating the regression line. Okay, so we can reason that because the value of A and B were also obtained from the same data points, and we lose 2 degrees of freedom when we use these points to estimate the regression line. So when with the same sample, if we are using 2 points, so those 2 points are already gone. So the adjustment of those 2 points, we have to put this particular n minus 2, because the degree of freedom will be lost because we do not have those points available with us. And that's what is the degree of freedom. The points which are available, or the data set which is available for you for any calculation, is the actual data set. Whereas if you are having this because you have already used 2 points, so and you now have the remaining points, and that is why we use n minus 2 when we are going with this particular SE. But in case of standard deviation, we use only one. You can say means the degree of freedom is n minus 1 because only one point is used in order, and that point is the point which we are considering as a mean out of all those points which are available. So that is, and because we are calculating standard deviation, and standard deviation is deviation about the mean. Whereas if we are calculating standard error, actually it is nothing but the variability. And when we are trying to get the variability, we have to lose 2 degrees. That's why n minus 2 is there. So this is something a little bit more enhanced, you can say. Okay, so this is how we can calculate the standard error of mean in case of you can say the Bright Future School case, right? This is a small case where you can actually see how the standard error of mean, and the same standard error of mean you will find in the model summary when you have gone through the SPSS process. So the same standard error of mean is calculated in the model summary if you want to see it. Okay. Yeah. So how will you interpret the standard error of estimate? What does the larger value of standard error means? Anyone? What does the larger value of standard error means? They see it's an error. Anyone? Okay, I will not waste much time. So like standard deviation, larger the standard error of estimate, the greater is the scattering. Because if you remember, we try to get the error from the line. Line we consider as the mean, and we have tried to calculate the error above and below the line. So higher is the standard error, higher will be the you can say farther is the point and higher will be the standard error. That's why larger standard errors of estimate, greater will be the scattering, means more far away the point is from the mean or from the estimated equation. Yeah, more dispersed, you can say. Madhvi, you have correctly said. Conversely, if standard error is 0, we can expect the estimated equation line is the perfect estimator. It means y minus y is 0 or y hat is equal to 0. It means whatever we have estimated, it is the actual exact line of the variable. Or you can say it is a perfect estimator of the dependent variable. So in that case, all the data points would lie directly on the regression line itself, and no points would be scattered around it. It means whatever we have predicted is nothing but the actual standard line. It means that prediction and the estimation, the prediction and the actual are same. Okay, this is something which is important. So standard error can be used as a tool in the same way we use the standard deviation, right? So if you try to find out this in depth, you can just have a look of this particular figure which is there, right? So here, if we see the scattering of the line, okay, so you can find it in this way by just preparing a bell-shaped curve over there, okay. But let me tell you, this is something which is a wrong way of doing it. So figure aside actually illustrates the bounds actually around the regression line. Another thing to notice over here is that if you just to try to, okay, let us assume that the observed points are normally distributed around the regression line. So we can expect to have 68% of the point, that is plus minus 1 standard error, and 95.5% of the points within plus minus 2 standard error, and 99.7% of the points in plus minus 3 standard error. So another thing which you can notice over here is this figure is that of the standard error of estimate and not measured perpendicularly. It is not measured perpendicularly from the standard lines, rather it is measured along the y-axis. So what is correct thing to do is that it should be measured from the y-axis. So that's why the measuring from the y-axis is correct rather than that of the along with the this particular standard line. Okay, so this is the correct way of measuring it. So at this point, we should state that the assumption that the observed value of y are normally distributed around the each estimated value of y hat, and the variance of the distribution around each possible values of y is same. If this second assumptions were not true, then the standard error at one point of the regression line could differ from the standard error at the another point of regression line. That's why I'm saying that if you are estimated something which is you can say around the line, will be wrong. Otherwise, which is perpendicular to the y-axis will be the correct one. Okay. These are the small things which you will not find in books. Okay, that I'm trying to make you understand. To what extent I'm successful, I don't know. But yes, these are the things which everyone must know and understand. Okay. So standard error of estimate can be used as a statistical tool which can use to make a probability statement around the interval around an estimated value of y hat within which this actual value of y lies, right? So for present example of you can say the bright future school we have just now, it can be 95.5% certain that the actual value of y will be within two standard errors of the estimated value of y hat. So we call these intervals around the estimated y hat approximate prediction intervals, you can say. So they serve the same function as that of the confidence interval in the normal case we do. Okay. So continuing with the example of the bright future school repairing case, we know that the estimated equation used to predict the annual repair expenses as y hat is equal to 3.755 plus 0.75x. And we know that if the school has a 4-year-old bus, we have predicted the annual repair of expenses will be 675. That's what we have done, right? So recently the standard error of estimate was 0.866, or you can say 86.60. So how it can be corrected? So if you can see it within, so combining these two things means if we have taken it within plus minus 1 standard deviation from the y hat, what it can be? It can include, or you can say we can calculate the upper limits or lower limits. So we can just see plus minus 86.60 rupees because we are making certain predictions. So that prediction has to happen with certain, you can say, with certain probability. That's why we are using it. So what the thing is, what can be the range? So because it's a prediction, so I cannot say anything correctly or anything you can say accurately. So there will be prediction, and prediction means I have to estimate within certain. But I have now an answer that it will range from 588 rupees to 762 rupees. Okay. So similarly, if we try to calculate it at plus minus 2 standard deviation, there can be much more bigger, you can say, higher estimate can happen, right? So if you have estimated this, so if you try to increase the scatter, if you try to increase the standard deviation particularly, then it will go a little bit higher. So keep in mind that the statistician, they apply the prediction intervals based on the normal distribution, and that's why standard one standard deviation is equal to 68%, two standard deviation is 95%, and three standard deviation is 99.7%, right? And this happens when n is greater than 30, that is for the large sample, or you can say, but here the sample size is very less. That's why our conclusion may be inaccurate. But the method which we have used, it actually is done to demonstrate the principle which is involved in the prediction intervals. So if we wish to avoid the inaccuracies caused by the sample size, we need to use a t distribution. Now, t distribution actually when is appropriate when n is less than 30, and the population standard deviation is also unknown. So we meet both these conditions because n is 4, that is, it is less than 30, and standard error is an estimate rather than the known population standard deviation. We do not know actually. So population standard deviation is not known. That's why we can use this particular t distribution in order to estimate this. So this is something which is a prediction regarding the t distribution. So I'm just skipping it because we have less time. Otherwise, I would have told you this also with a better and a greater accuracy. So linear regression analysis, if we do it using SPSS, we have covered this means there are a lot of things which can be done. So here, if we try to you can say, because I'm just skipping these slides because there are certain things more I would like to tell you, and the time is also running. It is already how much? Okay, we still have half an hour, but if you all permit, I would like to extend it to more half an hour if it is not finished, right? And I do not want to run down the slides in order to just, cover the things. I want to uncover the things for you. That is the most important what I want. So linear regression analysis is a tool which is having a lot of important applications. It is a way of testing the hypothesis concerning the relationship between the two numerical variables. Second, it is a way of estimating the specific nature, such as specific nature of relationship. And beyond asking, are water consumption and the population related, regression allows us to ask how they are related. And most importantly, it also predicts the variables for us with certain level of accuracy. That's what regression actually does for us. Okay, so if we try to establish a relationship between a consumption and the income, so I have already given you one file, which is the name of the file is country.sav file. You can just double click it and open the file and do the rest of the things with me. Okay. So is this file available with you, all of you? Yeah. Come on. Okay. So this is the data view and this is the variable view. Can you please see this and confirm me, because these are the variables which we'll be using now. Have you opened it? Yeah. Okay. Kushbuben has opened it. You are using you're better using this workshop in a good way. Yeah. Should I proceed now? What about others? Those who do not have SPSS, they can try it afterwards after downloading it. But you must have it, because okay. So let us now see. So this file, if you see, it contains different economic and demographic variables for the years, right? And it is running from 1965 to 2006, I suppose. And we will examine the aggregate personal consumption. So this will be the variable which we will be examining. So aggregate personal consumption and aggregate personal income. Okay. So PERSCON is the variable name, and PERSINS is the total spending in the total income for the country as such, right? So the more we earn as a nation, the more we spend. This can be the hypothesis, or formally, if you see, it will look like the hypothesis. You can say it can be written in this way, or you can say you can just write the regression equation in this way, that if x and y generally have a positive linear relationship, beta 1 is a positive number. If we have a negative relationship, beta 1 will be a negative number. If there is no relationship, then beta 1 will be 0. Okay, so this is something. So the theory says that the consumption depends on the income. Okay, and in language of regression analysis, the consumption is dependent variable and income is the independent. Okay, is that clear? So what we are going to study, this particular line tells us that more we earn as a nation, more we can spend. So it tells us that our consumption actually depends on our earning capacity, or more we earn, more we consume, or more we spend. Okay. So if we try to prepare the scatter plot, so let us construct the scatter plot using the two variables. How it can be done? Again, graphs, go to the legacy, the dialogues, and go to the scatter dot. Okay. Choose a simple scatter as such, and then insert the variable, that is aggregate. So y-axis and You have to be very, very careful while choosing, while putting the variables, because it's you who will decide what is dependent on what. Okay. So y-axis is the aggregate personal consumption, because consumption is depending on the earnings. So you can say the income. Okay. So in Y you will put consumption, in X you will put the income, and then press OK. You will get such type of scatter plot. Are you getting it? All the procedure is in front of you. Go on graphs, go on legacy setting, go on the scatter plot, choose a simple scatter, put the variables in y-axis and z-axis and press OK. How many of you are getting it as such? Come on. Kushbu Ben. Surbi, okay, you have done it. Great. Excellent. Yeah, Noreen, you have also done it. Great. Okay. Now, this is something, and if we try to interpret, now, if we look at the resulting plot, we can see that the point fall into nearly a perfect straight line. Correct? So this is an example of pronounced positive or a direct relationship, and a good illustration of what we call is a linear relationship, which actually it looks like. So it is called as a positive relationship because the line is having a upward or a positive slope. So it is going up. So it's having a positive slope. Another interpretation of the phrase linear relationship is simply as that the x and y are y form a line when graphed. It is actually forming a line, right? But what does the mean? What does that mean in the real world terms? How will you say? It means that y changes by a constant amount every time x increases by 1 unit. That's what is the, you can say, definition of a linear relationship. In this graph, the point from nearly a perfect line. So the regression procedure will estimate the equation that of that line which comes closest to the describing the pattern that has formed in the points itself. Okay. Let us do it with SPSS. Right? Go on, analyze, regression, linear. We have already understood and learned. Okay. Analyze, regression, linear. Are you doing it with me, everyone? Okay. Now put your dependent and independent as we have done before. Right? So, and if you will press OK for forming the regression itself, you will get these 4 tables. Okay. Model summary is that. One is ANOVA table, and the table of coefficients is there, along with the variables or the which are entered. Okay. Can you see this? Are you getting everyone? Okay. So the table of the variables enter or remove actually lists the independent variable in the model. Okay. So variables entered, these are the independent variable, whatever are there. Okay. So the SPSS refers to the variable having been entered into or removed from the model and anticipates the possibility that there are several models within the single analysis. Okay, so there can be various, you can say, changes in it. So in this particular example, there is just one variable, that is aggregate and the personal consumption. While we'll be going with the multivariate, then definitely there will be change over here. So the second standard part of the regression output is the model summary, which reports the statistics that are measured, or you can say it is the goodness of fit, you can say. So the statistics that is called as, you can say what this statistics actually means. It is the coefficient of determination represented by the symbol R square, right? and it is the square of R, or you can say the coefficient of the correlation, which is also reported over here. So as we note that the regression procedure, while least square method of estimation, the points better than just how good that fit is. We already know it, right? So it may well be the case that the best fitting line is not especially close to all the points. Okay, so for now we will just ignore the adjusted R square. We will try to just use it in our multiple regression model. Okay, so here do not consider even this, because this is a single variable model. That's why R and R square both are same. Okay, and where we use it as such, one is the perfect fit. Okay, which is and that point, and one, because one, it is very rarely we will get one, but this is also very good fit because it is giving you the value of R square is 0.998, which is closely or equal to 1 itself, right? So R square can range from 0 to 1, and which it indicates the extent to which the line fits as such, as I have already told you. In this example, we can say that it is having 99.8% of the variation in the, it is explaining 99% of the variation in the consumption, right? So the next table which we get in our regression output is the ANOVA table, right? And if X and Y are unrelated, the slope of the hypothetical regression line could be 0. That's what we have explained before also. So when we run a regression analysis with the sample data, we compute as the estimated slope over here. Typically, this slope is a non-zero one, because slope being 0 is a critical thing. So it is critical to recognize that the estimated slope is a result of the particular sample at the end. Thus, our estimated slope is subject to a sampling error, and it is a matter of hypothesis testing, because we keep on testing it. Ultimately, it is something which is to be predicted. That's why it needs to be tested. So in this instance, the null hypothesis being tested is that the true slope, that is V1, is equals to 0. Here with F statistics in the axis of 20,000, see the F statistics is very high, and the significance level is also 0. So we could reject the null hypothesis as such over here, right? Further is your this coefficients, if you see. So in the regression equation, the slope of the intercept are referred to as the coefficient. That's what we call. So we find both the coefficients are labeled as B. The intercept is called constant in SPSS, and the slope is the lower value. Okay. So from the table, we find that our estimated line can be written as consumption is equal to, if we use this particular coefficient in order to prepare the regression line, we have done it before also. We can just put it minus 125.228 plus 0.834, that is income. So this is, you can say, the equation. So the slope of the line is 0.834, which indicates that if the personal income increases by 1 billion rupees, the personal consumption will also increase, but by 0.834 billion. So it is not 1 billion exactly, but definitely a little lesser than, because people try to save also. Okay, so in other words, the aggregates, if we just take the country, the entire country as such, if we try to see it from that point of view, we can say that the country people consume more than 83 paise for each additional rupee earned. So here, if you are earning 1 rupee, 0.83 additionally 1 rupee you are earning. So 0.83, or you can say 83 paisa out of that is consumed. And what does this particular intercept means? That is the value of minus 125.228 says that if the income were 0, the consumption would be in minus. That is this much billion. So without any income, also, because when you are putting the intercept, you must understand that when the income is 0, the consumption will be in negative. It means it is, and there will be no negative consumption. What does this mean? This means, this makes a little sense, but reflects that our data set lies very far from y-axis. The estimated line must cross the axis somewhere, right? So in this instance, it is crossing at minus 125.22. Okay, that's what. And further, if you see it, from the hypothesis point of view, one standard test of the regression that judges whether there is a significant linear relationship between x and y. Our null hypothesis, or you can say hypothesis testing, particularly for this, can be written as h naught is equal to s naught colon b1 is equal to 0 and b1 is not equal to 0. So in the table of coefficient, the rightmost column, that is labeled as T, and the sig, this one which I have highlighted with red. So these represents actually the T test asking for the intercept and the slope which are equal to 0 as such, and the significance value is also being told that it is very significantly. It has come up very significantly. So in this case, we would reject the null hypothesis and say that the slope equals to 0 because significance value is 0. Is 0.00. You can say it is tending towards the 0. In other words, the estimated slope of 0.834 is statistically significant. So we can say that the thing which has come up is significant itself. And why not? It would be consumption and income. You understand that these things are directly related. So we can generalize from the sample to conclude that there is a significant relationship between the personal income and the personal consumption, as the value of the test statistic for the slope is 157.953. You can see that value particularly as such. Okay, 157 in the red, the t value, and the associated p value is approximately 0.000, meaning there is a significant, statistically significant relationship between x and y. We will not talk about there is an unreasonable relationship also, which I have actually given you one more file which is called body fat. So here, if you will prepare the scatter diagram between the percentage of the total body weight that make up the fat, actually is you can find out that it is nothing to do with this, right? So I'm just skipping this as such. Okay. Yeah, let me just yeah, these are certain assumptions which checking the assumption for the least square. This is important. So this is one exercise, you can do it yourself. Okay, using this body fat. This is also one of the file which I have already given you. So height is related to fat or not. How will you apply the regression? You can just do it yourself. DIY project, you can say. Next thing is there are certain assumptions of the least square regression. This actually, you can say, the method of least square itself. There are certain other names also, you can say. This actually term least square always appears, right? Referring to the criteria of minimizing. Why we are using it? Again, let me just revise the thing which I have already told you, that it actually minimizes the sum of the square deviation between the estimated line and the observed value of y. Because why? Because it is actually penalizing the differences. That's why we call it as a least square. So least square method will yield unbiased, consistent, and efficient estimates. And when the certain conditions are true, you can say. So what are these conditions which are subjected to be true? So besides the linear regression model suggests that there is a linear relationship between x and y, and the observed pair of the values, that is x and y, may deviate from the estimated line. You can say mathematically it is yi is equal to beta 0 plus beta 1 xi plus epsilon I, where xi and yi represent the observation of x and y respectively. B0 is the intercept underlying the linear relationships, and B1 is the slope of the underlying linear relationship, and epsilon is the ith random disturbance. You can say that is the deviation between the theoretical line and the observed value, which we have just now seen. So these are the things. Further, for least square estimation, the following are the assumptions which have to be considered. That is the normality. Okay, the most important thing. So at each point of value of x, the random disturbances are normally distributed. That is our assumption. And zero mean means at each possible value of x, the mean of epsilon xi is zero, because it cancels out the effect of one thing with another. Homogeneity of the variance is also called homoscedasticity. So at each possible value of x, the variance of can say variance of epsilon xi is equal to the sigma square, which is constant. Next is your independence at each possible value of x, or you can say that each possible value of epsilon xi is independent of any other value of ej xj, means it is independent of others. Okay, so if these conditions are not satisfied, the least square method is used, and the inference we develop and the test of the significance and the and any confidence interval we propose may be misled. So therefore, it is important to verify that we can assume that x and y have a linear relationship, and that the above, over and above, you can say the above condition, if it holds true. So the difficulty lies in the fact that we cannot directly observe the random disturbances, right? So epsilon I cannot be randomly observed, since we don't know the location of the true regression line. So in the lieu of the disturbances, we instead examine the residuals. That is the difference between our estimated regression line and the observed value of y. That's why we do it. Okay, so this is something which is, and these things are not in the books as such. I'm repeating. That's why I'm going a little bit more deeper, rather than, though I'm skipping many of the things, but still these things actually needs one complete workshop of 2 days in order to understand only regression part. Panel regression is another thing which can be done. So you can say, you can go with the time series data, you can examine the residuals using this cross-sectional analysis can be done, and the sample can be drawn from the population, and you can apply a cross-sectional regression. I'm just skipping this cross-sectional regression for the time being. How it is done, it's already there. Okay. This is about the cross-sectional regression. The output and all other things are also case-wise. The diagnostic is also. Now another assumption is the independence and the zero mean. So there are 4 assumptions about the random errors in the regression equation, and as we cannot observe the random errors, we will examine the residual to help the help us evaluate whether any of the 4 least squares assumptions should be questioned. So independence in this regression, we need not concern ourselves with the 4th, you can say, independence assumption. Since we are dealing with the cross-sectional data, if the cross-sectional data is there, you can just, and zero mean also is there, that is that the least square method actually guarantees that the residual will also always have a zero mean, which is depicted by the various tables which is there, and it can also be seen with the help of the what you call is the outputs which we get from the residuals. Yes, normality and the homoscedasticity. Normality particularly. So this graph is a normal probability plot, or you can say it is PP plot. If the residuals are normally distributed, they will be along a 45-degree line upward sloping the diagram. Okay. So this is how it will look like. So our null hypothesis that the residuals are normal, and to the extent that the graph deviates substantially from 45-degree pattern, right? So normality assumption should be cautioned. In this case, residual do not appear to follow normal distribution because it is far away from the straight line. So normality is violated over here, you can say, right? So as such, if we try to find out, so the normality, and let me tell you about homoscedasticity also. This is a graph, is a scatter plot of the standardized residual versus the standardized fitted or estimated values. Okay, so this graph can give us insight into the assumption of the equal variances as well as that of the assumption that X and Y have a linear relationship. So when both are true, the residual will be randomly scattered in a horizontal band around the residual value, which is said to be the zero. Okay, so residual actually that fans out from left to right or right to left, that signal heteroscedasticity of the variance, or you can say simply the heterogeneity of the variances, and heterogeneity of the variances itself is called heteroscedasticity. Right. So, like a curved pattern, it suggests a non-linear relationship. In our regression over here, we see the residual that vary more around the zero on the right side of the graph. Then they look at the left, right? And it suggests a non-constant variation. So this is for the moment. Particularly for this particular, you can say, graph is a bad news for us. So as with our techniques, a violation of underlying conditions such as linearity, or you can say homogeneity of the variance, or which is actually called as a homoscedasticity, this renders our inference to be unreliable. So we should not interpret the significance test in this particular regression itself. But there is a good news, is that some strategies deal with non-linearity or heteroscedasticity also. That is again one. Okay. So if we try to further observe it, if we try to see the coefficients from the line itself, right? So in the regression equation, the slope of the intercept are referred to as the coefficients in the models we know it. So we find both coefficients in the column labeled as B, the intercept which is constant in SPSS, and the slope is the lower value, you can say. So from the table we can find our estimated line, which can be written as the fidelity in the accidents, and this is another example which you can try to just follow up, right? This example, let me just give you the insight of this example also, where you can just see this. Let me just see what file I have used over here. This is about. Let me just give you because here you have to go with the cross-sectional analysis, which I have actually skipped off. So there is a file called states. If you just see the file called states, where you can apply the regression with the help of this number of fidelities in the accidents in 2005 as the dependent variable, and the number of registered automobiles in 2005 as the independent variable. Means number of automobile increasing will be affecting the fatalities, or you can say the accidents which are happening, right? So accordingly, if we try to interpret, because again it's a cross-sectional one, and just at least understand the equation as such, which is going to be. So here, if you see, as I've already told you, the fatalities in the accidents is equals to the scope, the slope of the line, and in case if there are no automobiles, still there will be some fatalities or some accidents will still happen, because you cannot stop the people walking on the road, and you cannot help them in saving themselves, even if they are not having the vehicle. So the slope over here, the line 0 indicates that the linear regression may not be applicable in this case as such, because the slope is coming from this. So the value of 216.203 means that even there is no vehicles, the accident will come. Okay, so this is something. So this makes a little sense, but actually reflects the fact that our data set actually lies very far away from the y-axis. The estimated line must cross the axis somewhere. For this purpose, it is 125.228 as such. So if you try to examine the residuals, particularly in the time series, you can do it also. Okay, you can apply the regression particular time series. One more file is there, which is called the country file. Okay, so you can create the scatter plot, and this is the scatter plot which has been created. And does it appears to be linear, or how it is appearing? You can just analyze with the help of what I have just now told you about. Okay, so if you apply the regression, you can just go on analyze. Do you have this file? If you want to do it with me, you can do it with me. You can open the file called country. Okay, so here we are going to apply some just multiple regression itself over here. So just open the file country, and just go with this analyze, regression, and linear. Okay, those who have installed their SPSS and want to learn this, they can also learn. We have already run out of the time, but this is something where I would like all of you to just do it once with me. It will take more 15 minutes. RTG has already come to just tell me that your time is over, isn't it, RTG? Glad to see you after a long time.
सर आपका समय तो सर कभी ओवर नहीं हो सकता, आप बिल्कुल जितना आप चाहें.
नहीं ज्यादा समय नहीं लूंगा, 10-15 स्लाइड्स और है तो मैं दिखा दूं, क्योंकि मैंने प्रिपेयर करी है सबके लिए, तो दैट्स व्हाई आई जस्ट वांट टू शो इट. दैट इज रवि जी का फोन. No, it is not stuck. Actually, I was talking with Ravi ji, and Ravi sir is saying that there are heavy rains going in Jaipur, and any time we can be offline. So let me just run you through this particular thing. So please open this. We are not stuck anywhere. Don't worry. Okay, Ravina, you are concerned about that. Anyways. Fine. So let us try to for installation of SPSS. Sumanna ji, you can talk to me offline. No issues. I will tell you how to do it. And if you want, I can give the software also. No
okay, sir.
Okay.
Thank you.
So,
Keep
you're most welcome. And those others also, those who want this, this is something which I can do for you. No issues, because main purpose is learning. So let us get back. Okay. And in case you are having any problem, you can call me up. I will give you my number in the chat box itself. And if you want some exercises or some offline session to happen in your institution, you can call me anytime. Okay. Yeah. So let us just proceed further. Just open this file country. Okay. Open the file country. And let us just, you can just prepare the scatter plot of yourself by yourself itself. It is showing that there is not a good relationship between these two, because it is going far beyond the line itself, right? So we will apply the regression analysis. So go on analyze, go on regression, and go on linear. Okay. And then you have to carefully choose the dependent and the independent variables as such. So we are trying to predict the number of cars if the population increases, right? So population is the dependent variable we have taken, and independent is the cars in that, right? So here we go with press statistics, and over here, if you see, just try to put ticks on these, because we need the estimate, we need the model fit, we also need the descriptives, and here the residuals will be tested using. We will be applying the Durbin-Watson test over here. Okay, and we will be doing with the case-wise, you can say, diagrams, and we will just consider the outliers beyond true standard deviation. Okay, and please notice that there is a series of points. If you try to see this particular graph as such, there are you can say there are certain series of points which are below the line, followed by certain series above the line, right? And again below the line, and so on. So this pattern suggests that the residuals are not dependent of one another. As we move through the time, positive and negative residuals tend to cluster. And when residuals are independent, they fluctuate randomly through the time. Repeated runs of the positive and the negative residuals suggest that the residuals are dependent on one another. Okay, so this actually is how it actually depends. Okay, so just press the continue button and go to save. Okay, now in save, you have to select this standardized, and then you have to go with, because we will be going with the standardized residuals also. That's why we are selecting this as such. Okay, and then put on plots, you can say. Now here, because we will be examining the residuals, so Z residuals and Z pred. So these are the two things which you have to take as Y and X, because the analysis which I have just now told you about was of these particular residuals. Okay, and now you have to go for this normal probability plots, and then press continue. Okay, and then press OK. The entire process is in front of you. Okay. Those who have skipped any step, you can just do it now. Okay, fine. So if you press OK, there will be this. There are plots which are given. Right, now see. The early residuals are negative. That is, these are steadily approaching towards zero, and then the positive, and then they turn again into negative. So this indicates that the residuals are not dependent. That's what I just told you before. If you plot it in a line, or if you plot it in a scatter, it will come as such. Now just observe this summary. So what is the Durbin-Watson test? It is far below the range of 1.5 to 2.5. Hence, this is shown as the first level of auto correlation. It means that the values are not independent of each other. Okay, and the standard error of estimate is also very high, if you see. Okay, so these are the things which you have to observe. So if you try to analyze it further, right? So that the table which are given as such. So the table of the variables which the table or you can say the variables entered or removed. If you try to see this table, this lists the independent variable in the model. Thus, SPSS actually refers to the variable being entered or removed from the model, and it anticipates the possibility that there are several models within the single analysis, as I have told you before. And there is just one variable which is called population over here, because we have considered only one asset. So second standard part of the regression output, or you can say the model summary reports, the reports as the reports that statistics that measures the goodness of fit. That is the R square. Okay, so the statistics is called the coefficient of determination, represented by the symbol R square. It is the square of R, or you can say the coefficient of the correlation, which is also reported. So in this example, we see that the changes in number of cars account for 75% of the variation in the population. Okay. So as we see it later, it is possible to have several independent variables, and we may want to examine the regression models that contain the different combination of those variables, right? So we also know that the regression procedure via least square method of the estimation gives us the line that fits the point better than any other, right? We understand that. And one is the perfect fit also, where we have got certain point less than that. Okay. So ANOVA output, if you see here also, so here if we run the regression analysis with the sample data, we compute an estimated slope, right? Typically this slope is non-zero because of the adjustment of the you can say the errors which are there. So it is critical to recognize that the estimated slope is a result of a particular sample at hand. Thus, our estimated slope is subject to the sampling error, and this is macro hypothesis testing. And we always test the hypothesis using this particular ANOVA table. And their hypothesis being tested is that the true slope, what I have already told you, the language of the hypothesis will remain same. Okay, that the true slope, that is V1 equals to 0, where with the F statistics 114.271 and the significance level is 0, what we will do, we will reject the null hypothesis. Okay. And further, if you go with the descriptive statistics, mean and the standard deviations are also given. And if we assume the normality is, about 95% of the time that the observed value point should fall within the 2 standard deviation, which we have studied about the estimated error of this SEE, that it should be horizontal to the axis, not to the distribution itself. So here, if you see what does this particular the mean and the standard deviation is already given, and the standard error of estimate comes to be 9.4. We have already interpreted it before, because this is something which we have observed with the measure of the variability too. Okay, so it is much smaller than the standard deviation of Y, and we can see that it may not be a good fit. Okay, again, the interdependence and the zero mean, if you see, it is given as such, and the same interpretations which we have made before. I have just run this in order to make you understand that what are the procedures in the SPSS in order to do it. Otherwise, the interpretations are same which we have done before. It is just a repetition of it. This and you can even this is another exercise which you can do, and there is another file, NSCOM. In that file, you can do another analysis. You can try another analysis with the help of the regression coefficients and the dependent and the independent variable, and try to understand it in a better way. Okay, so this is how the regression, actually multiple regression I could not take now, because up till here I think the points must be more clear. There are more slides particularly for the multiple or multivariate regression. Maybe next time. I hope up till here I think you are able to understand. So this is something which needs to be understood, and I hope to what extent I have done the justice today, I do not know, but yes, far beyond that, I can say that yes, there is something which I could actually convey over there. Thank you so very much, all. And if you have any questions, you can just raise it, or you can give it to Ravi ji, and I will answer those to him and he can convey it to you.
Sir, first of all, thank you so much, sir, for the wonderful session, sir. As always, as always, sir, there is no question regarding this, and everyone is happy. You can see in the chat box also. It was really an informative session, hands-on session, and Professor Pava likes hands-on session actually. Always, uh, always give examples of practical knowledge, and I must say everyone is happy. And I will surely share the SPSS software link. I will. Pava sir, please.
Yeah, a lot of questions
Share
I
with
couldn't
me.
take in between. Actually, I wanted to cover more, but yeah, means
You can cover up to full day, sir. I know that.
Full day, sir. 2 hours is too less for sir.
Hmm.
और सर आपकी modesty आप पूछ रहे हैं. I don't know whether I've been able to do justice, more than justice, if there is any word that you always do.
I wanted to cover that multiple regression. Actually, what the thing was, most of the time with the feedback which I was getting from the participants, that sir, we do not know anything about regression anyway, and we just wanted to learn it from the scratch itself, and that is how actually they wanted it to learn. But the thing is that that is again because starting from the scratch and taking it to the you can say to the higher level, it becomes sometimes very, very difficult. So, but yes, to the best extent, whatever I could do, I have done that, because time is the limit. If Raviji
Professor
provides me
Pava sir
one
always give extra time also.
extra time is okay, but people sometimes they are fed up of that. That yeah, when this Sardarji will stop,
No,
we
no,
have to
sir,
go home.
but you know, every day, every time the participants enjoy your sessions, sir. And any question you can ask to Professor Pava sir. If you have any question, any feedback you want to give, you are most welcome. You can unmute yourself. Any feedback up to till today, if you feel anything regarding this faculty development program, you can
Yeah,
suggest us.
as promised, I have already shared my mobile number in the chat box itself. So those who want, or those who want to, you can say, be in touch with me. You are always most welcome, right? And in case, because actually what happens is that most of the time when we are studying these technical things, hands-on session, and that too, either if it is a online, then it should be a longer one. If it is offline, it is always better. Okay, so this is something where if you want, Raviji can organize one complete workshop, particularly on regression,
Right,
because
sir.
this is something which is a basic thing which actually binds many things. That's why when we were discussing, Raviji, if you remember that we talked about the hypothesis testing. Once it is taken, then only I will take regression.
Yes, sir. Yes, sir. Yes, sir.
So that is the thing which
I always took your help, sir, before I organize any event on particularly research methodology.
Yes, Ravina, I have a YouTube channel. You can just see that. Even most of my videos are on YouTube channel of Inspira also. But yes, I have that YouTube channel.
Yes.
If you want particular clarification
I
on
will,
any of the
yes.
topic, I can
And I will
recommend that.
also share the YouTube channel of Professor Pava sir also, and Inspira Research Association. You can search.
Channel name is with my, you just put my name, you will get two channels. One is having blue turban and another is having red turban. So you take the blue one, okay? Red one is something personal. You will find find me singing over there some songs and other things which is of no use for you. Rather, you will abuse me for that. Yeah. Okay, so the blue one is a better one where you will find something which is useful for all of you. Okay.
Thank you, sir. And I think there is no question. So I request once again to every participants to please switch on your videos for screenshots.
See, Raviji, no question. It means the delivery was not good.
No, sir. It means it was
So it
wonderful.
means everything is clear.
Everything. And you can see the faces, sir. You can see all the faces. Sir, see, sir, you know that today every participant is smart, sir. If anything, they can ask directly. So
Okay.
there is no question, sir.
Please send me the screenshots and the photographs you might have taken, Raviji.
I will send. I will share.
Sir,
Okay.
our pleasure to hear you. We gain
Thank you.
too much knowledge. Thank you. Thank you so much.
Thanks a lot. Thank you. Thank you, Khushbu. I think you have learned many things because I found you very active in actively responding the things you have done it on SPSS also. That's great. Previously, you were not having that. You downloaded it and done it. So this type of dedication is required for for learning certain things.
Yes, sir, still, participants are really dedicated, sir. In every session, they are so interactive also with all the resource persons, and they are very active, sir.
And Ravi sir, some of the participants are so regular with Inspira's FDPs and conferences that they feel like a family. Yes, some of the names are so familiar that we feel that they're the part of Inspira family.
Every time, actually, they learn new things, ma'am. So,
actually, what the thing is, what happens is that when we are going in technicalities, actually, this is my habit. I always try to go do something that, agar aisa hota, fir kaisa hota? And I try to get many things which are really not in the books. You will not find. By this interaction itself, you could have understood. You might have learned regression at many instances, but the way this is done, I'm satisfied with that. That whatever I have delivered, this was something very much fulfilled. And if you take it seriously, na, definitely. Sumanna ji has been our, I think,
Sumanna ji, regular participant.
Before also, ma'am.
Very nice explanation, sir. Really, no book can be found that with such explanation. Practical
because nitty-gritties are there, which I have my level best to
admit the same practically.
Yeah.
Thank you.
Anyways, thank you. Thanks to all for tolerating me for 2.5 hours approximately. Thank you, and thanks for the good comments you have written. Still, thank you.
Thank you, sir. Thank you so much, sir, once again. And for the formal vote of thanks, I would like to request Dr. Megha Sharma from Mehta College and Institute of Technology, Jaipur, for the formal vote of thanks. Dr. Megha Sharma.
Yeah, I'm thankful to Mehta College also. I forgot because this is something which
Mehta College and Swami Sahajanand College of Commerce and Management, Gujarat also.
Okay, this is a joint.
Yes.
Okay.
And it is a very both institute is well known, sir. And Swami Sahajanand College of Commerce and Management, it is an autonomous college of commerce and management.
You might have got for a NAC grading. Autonomous colleges might have some NAC grading also.
Yes, sir. B+. They got
B+.
Yes. Yes, Dr. Megha.
Am I audible?
Yes, to yeah, madam, you are audible and you are looking so beautiful.
Thank you so much, sir. So your perception is beautiful. That's making me beauty. That's it.
Thanks for the compliment.
Very good evening to everyone and all the dignitaries present over here. On behalf of Inspira and Mehta College and Institute of Technology, I extend my heartfelt gratitude to Dr. Manvendra Singh Pehwa for delivering an insightful and engaging lecture on regression analysis during our faculty development program on advanced research, methodology, and data analysis. Yes, engraving strong foundations for interdisciplinary and noteworthy research by utilizing advanced tools. So truly said, future outcomes are based on past decisions and also influence relationship between two variables, whether independent or dependent, while interpreting the finalization of any theory, any hypothesis. Your session not only dependent on understanding of theoretical foundations of regression, but also shed light on its wide-ranging applications in areas such as predictive modeling in business and economics, forecasting trends in finance and marketing, analyzing relationship in social science and policy planning as well, medical and clinical research, where it helps in identifying risk factors and predicting outcomes. Yes, surely, sir. In any type of field, in any sector, regression analysis is the must. prerequisite. Your expertise, clarity of explanation, and ability to connect theory with real-world application greatly enrich the learning experience for all participants. The session was not only informative, but also inspiring and significantly contributed to the success of this FDP. Thank you once again for sharing your valuable time and knowledge with us. Sir, we look forward to more such enlightening collaborations in the future. Thank you, Ravi sir. Thank you, Aarti ma'am. Thank you all the team. Thank you so much.
Thank you so much, Dr. Megha, for the beautiful vote of
Most
thanks.
welcome, sir. Most welcome.
And
My
once
pleasure.
again, I would like to thank Professor Pava sir on behalf of Inspira, Mehta College and Swami Sahajanand College for always, spare the time for Inspira Research Association. Sir, we would like to invite you very early. we will invite you soon in the offline program also. We are planning to organize in the month of September.
Looking forward to come Jaipur anytime.
Yes, sir. Yes, sir. It is your hometown, sir.
Of course.
Yes,
Yeah, I'm having a house over there, and eight years spent at Manipal University,
yes,
Jaipur was very, very fruitful over there. Right, Jerry. Thank you so much. Thank you, everyone.
Thank you so much once again. Thank you, Dr.
Thank you
Aarti.
so much,
Thank you,
everyone.
every participant. Thank you. Thank you so much. Keep learning. And we will meet tomorrow at the same time, 5 p.m. on the session, Factor Analysis and Structural Equation Modeling by Dr. Hitesh Parmar from Sardar Patel University, Gujarat. Thank you so much. Thank you so much.